So you have been speaking for quite some time. I don't know I was on mute. So can you guys hear me?
Yes, we can hear you and we
Hello.
can see your screen.
All right, no problem. Thank you. So welcome to today's live coding session, and this is the last live coding session for this stage. And so in this stage, the course content we have tried to introduce what Kubernetes is, how Kubernetes works, and we've shown some code snippets and all. The live coding session should generally have been focused on a practical experimentation with Kubernetes clusters and what it entails. Sorry, I mean Kubeflow, not Kubernetes. Kubernetes was the last one. So using Kubeflow on Kubernetes, what it entails and how to use it. But then due to the limitations based on the requirements for a successful Kubeflow orchestration, we have been more focused on completing some of the pending tasks we were working on in our last live coding session. So in our last live coding session, we deployed an app using Docker. So we spinned up two containers. We made the containers communicate with each other in this or using the same network by creating a network for both containers. And we also saw what Docker Compose is, where with Docker Compose you can provision all of your containers and infrastructure at once without having to create them separately before linking and joining them together. So what we'll be doing in this live coding session is almost um sorry. So what we did in this live coding session is almost similar to what we did last live coding session. The only difference now is that in this live coding session, we'll be um we'll be using Kubernetes. That's the Kubernetes itself that I've been talking about. So we'll be deploying using Kubernetes rather than Docker. So we have seen that we can use Docker containers normally to make all of this deployment and all. But then aside from using Docker naturally, there's also the orchestration platform called Kubernetes, which is what we'll be showing today. And just like when we started Kubernetes, I think I recall saying that majority of these platform orchestration platforms we use YAML syntax whenever we are writing declarative files for them. So YAML syntax is the standard, and even the Docker file that we created, the Docker compose file we created in the last live coding session, everything was written using YAML syntax. So let me switch my screen and then share my window so you guys can see everything I'm trying to do. So today we'll be using Kubernetes to try and get all of this up. So I don't know if you recall I am using Minikube version of Kubernetes, and I think we should all recall that I went through the process of installation of Minikube as a Kubernetes engine in the last one of our previous live coding sessions. And then we know that to start the Minikube, we need the Minikube start command. So there are two ways we can. If I play this container now, Minikube can get started, and another way I can do this is by using the Minikube start command. So I'll come here and do Minikube start. Okay, so wait for our Minikube to get started on our system. So today we'll be using two YAML files, and basically just like how we did it in the last live coding session where we created each container separately and then connected them together before we then use Docker Compose to create both containers. We'll be doing something like that for here also, where uh, we'll be using Kubernetes Minikube to just deploy two of them. So we'll first deploy them separately using kubectl apply, and then we'll deploy, okay, then we'll deploy both of them using a combined deployment workflow. So the Minikube is still starting. We have to wait till it is up before we can do anything. So let's just wait till it comes up. Okay, so we are now using the mini cube cluster. It's done already. So now if I do um kubectl get pods, you can see that we have no resources because we have no pod created. I remember when we finished the installation of minikube, we spinned up a very simple pod and we saw the pod life cycle and the stuff like that. So before we do that, now let us go into each of the file that we'll be using. Okay, so what I did was I have the deployment file for the backend container here. Okay, so what we'll be doing is based on this we'll try and create something for the front end container basically. So backend deployment blah blah blah. We don't have, do we still have, let me check if I have my images ready. So images, so remember correctly that we have our images. We are using the latest version for our front end. So our front end latest version is version 4, and then for our back end latest version for the back end is version 3. So those are the two versions of images that we're using. So one thing that I believe that we have already noticed is that um, Docker is a very, or even if not Docker, container images is a very key tool in what we have been doing so far for like the past two stages. Before you do anything, you need to have like a Docker image that you can use to start a container. If there's no Docker image that you can use to start a container, then there's no way you can host your deployment process or your organization workflow on, be it Docker or be it Kubernetes or whatever platform you want to use online. So as long as you want to use Kubernetes, or you want to follow the microservice architecture, you need to understand how to create Docker images for your apps, and then these Docker images is what is going to serve as source of truth for whatever platform you want to use when you are spinning up or destroying infrastructure. So now let's go to the backend file. So just like we had for the Docker file, this file here is a backend deployment script.yaml. Okay, so this backend deployment script, this is what it does is that it helps us to deploy the backend. Okay, um so let's go through it of this. So what does the API version do? I think before we do this, let me try and show this Kubernetes documentation. Let me try and show this in the Kubernetes documentation that this is what we're trying to do. Okay. All right. So understanding Kubernetes, blah blah blah. Getting started concept. I think exactly. So containers. I just want to show if you can see everything about all of the files. Let me see. I think we saw it one. Okay, overview. So traditional deployments, blah blah blah, cluster architecture, blah blah blah, then containers. So container images, workloads, what's next, blah blah blah, services. So service in Kubernetes, exactly. So this is defining a service. So we'll just go through all of this, but then so let us just, so we won't waste too much time. So this is the deployment script, and I think most of us should have this because I forwarded this zip file to um I forwarded this zip file to I forwarded this zip file to our Slack page if I remember correctly. So these are our replicas, blah blah blah. So the first thing is we specify the API version. So this is like a standard it's just like when one is writing HTML code. If you're writing HTML code, you start your HTML file using the HTML tag basically. So it's not really but this lets your Kubernetes cluster knows what version of Kubernetes you are trying to work with. So there are multiple versions of Kubernetes, and we are using the apps V1 version. So um, if you come here, so the API version mostly is V1, and there are a lot of different versions that you can use. I'm trying to get the actual documentation page where they have okay Minikube. So this is where the Minikube say deployment blah 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 kubectl get pods exactly Kubernetes basics creating a cluster. I don't want deploy an app. I want to see if the configuration config map. So they don't have anything here about, unfortunately they don't have anything here about the YAML file. It will be somewhere actually. Let me see. YAML file. Exactly config YAML. This is the documentation. But then I'll try and get the link to what exactly I'm looking for and send this. I think I saw it a few days back when I was just surfing. So this is the API version. Then we need to specify what kind of service it is, what it is that we are doing basically so this here we are saying that this is a deployment. Let me see if I have one for service here. So you can see that here I have the kind service. So if we come back to this documentation aspect, they have a lot of different things I can create. So you can deploy your app, you can expose your app, you have configurations, and then this is services. So we have different services. You have a deployment service, you have like the app, there's a deployment, there's a port service, and all of the likes. But most times when you're writing a YAML file that is going to be starting a container, what we are going to be using is the um deployment kind. So this lets Kubernetes know that what we are trying to create here is a deployment kind of it's a deployment basically inside a pod or inside a node basically for our Kubernetes. So now we need to provide metadata. So metadata is just the name. So just as we have been using previously. So this is the backend deployment. So backend deployment is the name of this deployment in our Kubernetes node. So if you come here now, you see when I did kubectl get pods, we don't have any pods running. If I do something like kubectl, I think get node, we should see a node. So we have our mini cube. So the node we are on is our mini cube. So mini cube, as long as the mini cube is started, you have your node ready. What of the cluster? So it doesn't have a resource type cluster, but there's also a way where you can check your cluster information. But the way minikube works is that you have a cluster once your minikube is starting, and then you have a node called minikube, and that is where all of your deployments are going to be going to. So we now have something called spec. So you can see spec as short for specifications. Okay, so inside the specifications we begin to define some stuff. So replicas, what replicas does is that replicas tells Kubernetes the minimum number of instances that you want, and this replicas is very very important, especially if you are trying to do like something about scaling up and scaling down. So what does replicas allow you to be able to do? So what replicas does is that it allows Kubernetes, when Kubernetes is orchestrating your container platform, it ensures that for this particular container that you are trying to create, there is always this number of replicas available at any point in time. At least the minimum amount you will get is this number. So if you put your replicas to 0, what will happen is that there will be periods where your app will not be accessible, or at times where you have very very low downtime, then your app will scale down to 0. There will be no instance of your app available until a request comes in. And immediately a request comes in, your Kubernetes is intelligent enough to know that a request has come in. I need to now create one instance of this particular app. So what this helps to do is, if you are in an environment where you are paying a lot and you want to ensure that at particular, I think I used this example that time also, where For example, if you have a service for students, and you know that students will only be in school between, let's say, 8 a.m. and 4 p.m., and you know that between like 6 p.m., 7 p.m. till the next morning, there might be zero request to your app because a lot of students will be at home working on stuff, and you only created a service that is used during the day when students are in school. So this kind of feature is going to help you a lot to save cost, because you can make your replica count zero, and Kubernetes will ensure that that particular instance scales down to zero for those periods where there is no downtime. And when you scale down to zero, it means you are not using any resources, and the cost of everything that you are meant to pay for will not be paid for that particular period in time. So that's what this is doing. So this is the selector. So what this selector does, the selector allows us to be able to refab to this particular deployment from other Kubernetes app, other Kubernetes deployments that we're going to be making. That's what this here is doing. So all of these are just template data. So in the spec, another very important thing for the template. So under the template tag, we have the metadata of the labels of the app. So all of these are just metadata. Anywhere you see metadata, there are things that can be skipped, but we just like to define it so that you'll be able to you'll be able to effectively you'll be able to effectively catch how do I put it? You'll be able to effectively catch your deployment if you want to make changes to it. If you don't have all of this, then Kubernetes will randomly assign names to your deployment, and if names are assigned randomly, then you cannot specifically say this is where this deployment is, unless you have a code that also stores the name immediately you are done deploying. So that's what we do. Then yeah, this is where the containers are. So the name of the container is going to be called the backend container, and then this is the image it is going to be using. So as I've said, the image it is going to be using, we have to now go back. What's our backend image? We have to look for our backend image. But then, let me see if this will work. So our backend image is Oadenion app 2 backend. So Oadenion app 2 backend v2. Copy it. Okay. So let me remove this. So this is the image that we're going to be using. And then we know that our container port, what's our backend? What port is our backend using? I think if I can remember correctly, let's go into our app. So our backend, which is app 2, yes, this is the backend, is running on port 9000. So the container ports where our backend is running on that we need to expose is what? Port 9000. So let me just make this port 9000. I'll save this. So this is the for the backend deployment. So I intentionally omitted that for the front end so that I'll be able to create it together. So let me call this, let me create a new file. I'll call this front end deployment dot yaml. Okay, so this is the front end deployment. So just as we know, what we need to start with is the API version. So this is the API version. Let me just come here and lift most of this stuff. Control C. There's no crime in copying and pasting your code whenever you need it. So I just need to come here and then change this. So this will turn to front end deployment. Then the replicas will also be one. So this app now is our front end app. Okay. And then is also the front end app. And then the name of our container is also going to be called our front end container. And then we are going to be using app one front end version 4, if I remember correctly. Okay, so our backend should be version 3 and our front end is version 4. So this is correct as version 4. Let me come here and change this to version 3. Okay, and then we need to change our port. Our port for our front end is port 7000. But we also need to include one more thing. What we need to include now is we need to include an environment variable. I don't know if you remember correctly, if I open up the Docker Compose that we used the last time, you see that after starting the front end, we had to add this environment variable to show you have to add this environment variable to show that the Sorry, can you guys hear me now?
Yes, can I hear you, sir?
Yeah, thank you. So we had to have and we needed to add an environment. Okay, yeah, you can ask your question.
Okay, sir. Please, I'm sorry to ask this question. Up to now, sir, I've not been able to resolve the issue of Kubernetes on my system. But the option I want to suggest, sir, like since you said one can go through the cloud, I have an account with AWS, which is already loaded. I don't know if you may permit me to share my screen. I don't know how to go about it. How to even be running basic Kubernetes command line. I don't know how to go about it. But
Uh
I have an account already. Maybe you can just
I
walk through me.
think if we say we should do that now, it will take a lot of time that we don't have because there's another session after this one. What I'll do is I will look for a comprehensive YouTube video that gives a good introduction of using Kubernetes with AWS using the EKSTL2. So you have to, like, when you start your Kubernetes on AWS, then there's a way that you connect into the shell of your AWS instance that is running the Kubernetes. So it's just like as though you had a computer on the cloud, and on that computer, Kubernetes is being run. So they will give you a way to access. So you'll be given a terminal, and that terminal you'll be able to use it to access your Kubernetes deployment, basically. So I will try and provide you a video because if you say we should go into that now, we won't have enough time to try and wrap this up. Okay, yeah. So let us continue. So as I was saying, for the Docker Compose, if you remember correctly, for the Docker Compose, we had to, like, create an environment variable because the whole creation of the environment variable started from the fact that we wanted our URL in the app to be different for when we were testing locally and when we started deploying. And because we know that we wanted to be able to change this without having to go into the app, because we'll be using an image and we cannot keep stopping a container every time we want to change an image. That was why we revamped to an environment variable. So this environment variable that we provided using Docker Compose, we also have to provide it for this container that will be running this particular image. And to do that, you just use env. Okay, and if you use env, then you need to provide the name of the env. So the name of the env, okay, is the backend URL, or I think we call it base underscore URL. Okay, and then the value of this one now is going to be HTTP. So just as we have it here, okay, just as we have it here, let me pick it up, Control C, and paste that here. But what is going to happen now is that instead of using the container itself as the URL, now we need to do something. We are going to create something called a backend service. So instead of having the container here, what we'll be connecting to is the backend service on Kubernetes. So we have not created the service yet, but I have the files to create the service here. So we'll go through the file to create the service and then we understand what is going on. So for the um as I was saying, for Docker itself, Docker, when we were trying to connect two containers together, what we did was we created a network, and anytime we were starting the Docker container, we added each of the container to that network, and then we use the name of the Docker container itself as the URL or as the base URL that you can use to access that container. But for Kubernetes type of deployment, what we need to do is we need to create a service. So it is that service that we'll be connecting to. So um any any app that is in the same Kubernetes cluster can connect to that particular service on whatever port that you want it to be. So let us go into the service creation. So you can see that here now, previously for this we had kind deployments, but now our kind here is backend. The kind is a service, and the name of this is the backend service, and it is this backend service now that we are connecting to this our front end here as the URL. I don't know if that makes sense. Because if we're on our local system, what will be here will be what? 192 or local host 192.178.1. Blah blah blah. Or it will be local host. That's if we're on our local system. When we move to using Docker, what will be here will be the name of the backend container that is running the Docker image. But now that we're using Kubernetes, for each of them, what will have to be here is going to be the name of the backend service that you're creating. So it is this backend service that any other node, any other pod that is in this same cluster, in this same node group, will be able to use to this particular pod that you're creating based on this. So that's why we have this. And then you can see that for this cluster IP now, so what we are, when you are creating a service, you are going to specify a type. So we are creating an IP and then the port. So it's just like if you remember for Docker, or let me see if we have it in our Docker Compose. Yeah, when we're running these apps, this is Docker Compose. When we're running this app, you can see that we have something here where we have like 5,000 to 9,000, 3,000 to 7,000. So if you remember correctly, you know that 3,000 is the port on our local system, and then 7,000 is the port inside the container. That's basically what this is. So Docker was like interfacing with our local system directly. So we have a port on our local system, and we connect it to a port on our container basically. But now for this one, what we are creating now is a backend service, and it is the backend service that is now going to be interfacing with our own port basically. So it is this service that we have created that will be able to use to connect other node groups to each other, and even we on our local system will be able to use to connect to each other. So the target port here that we are trying to target for this particular app is port 7,000, because we know that's where this app is on. And then this one can be anyone. So I'll leave this as 5,000 since we don't have any other port on 5,000. And you can also see that we have a selector. So for this service we are creating, we have a selector that we are placing inside this service. So when we're creating our backend scripts, you know that we had this place called selector. And this part of the selector, in mass labels, we named it backend. So anywhere you want to use the selector in any other service that you are creating, it is what you specify here that will be able to use to match this particular app that you're creating. So that's why in this service here, when we are selecting a selector of the app, we are selecting the backend service of the app. And with this, we should have this ready to go. So the first thing we'll be creating is the service. Just as we had when we were using Docker, we have to first create the network before we started the container. So yeah, and you know that to start anything on the Kubernetes service, you need kubectl. So kubectl apply. Okay, and the file we are going to be using, I'm using the backend service .yaml. But then should we start with the service, because we need to have the app first before we can get the service. Okay, let me start it this way. So kubectl apply from the file the backend deployment scripts.yaml. Okay, so you can see that deployment.apps, the backend deployment has been created. So if I do something like kubectl get pods, so you can see that we already have a backend deployment that is created based on this backend deployment. But there's an issue now. You can see that our image is not being pulled. So this is an error. This is called the image pull error. So the reason why we're having this image pull error is because the Kubernetes cluster is not able to access our image. Basically, it does not, it is unable to pull our image from wherever the image is. So, and I'll show you how you can sort that now. To sort that, the major reason why is because Kubernetes is a bit different from how Docker works. Docker is able to interface with our local system directly, but Kubernetes does not really Kubernetes does not really, how do I put it? Kubernetes does not really have access to information on your local system. It is an isolated environment on its own. So if you want to use an image in a Kubernetes system, it has to be in a place that is publicly accessible by Kubernetes itself. Okay, and the only way we can get that to work is if these images now that are on our local system, we move them from our local system to Docker Hub or to any other place that is well accessible. So what is just like when you, just like as I try to explain what Docker Hub is, it's just like when you have a GitHub a GitHub repository. So whenever you clone the repository and you write your code locally, whenever you clone the repository, you write your code locally and do all of those kind of stuff, you won't be able to, no one that is also collaborating will be able to see the changes you have made until you do what? You push it online. So when you push your code from your local cache of the repository into the global one that is available online, then anyone that is also working on that same repository can now run a git pull command. A git pull command will now be able to update their own versions of the repository to now have your own changes. So that's basically what is happening here also. So we need our images that we have here locally to move from our local system to a place that Kubernetes can what publicly access it. So to do that now, I will move this image here, and that is why we needed from the start. You can see that when I was creating all of these images, I added my username, and I think I showcased it then. The reason why I needed to add my username, because OADNIO is just like when you are trying to push to a GitHub repository, you need to know what repository you are going to push to. So the way Docker Hub works is that every repository that you want to push to, you push to the username. So your username acts like your repository, and that is what you use. Your username is what act like your repository. So if I come here now, for example, I think I have here somewhere where I have Docker Hub opened. I should have Docker Hub open somewhere. Can't I leave full screen? Okay. Should have Docker Hub open somewhere. But let me just open a new one then. So this is Docker Hub. Okay. So if I come in and I log into my Docker Hub, you would see that I have a lot of different images on my Docker Hub already, and these images all follow the same format where my username has to be there first, and then slash the name of whatever image it is. So these are like the different images that I've pushed over the last couple of years and stuff like that. So let me come back here now and now push these images. So the backend, I'll just push the ones that we need. So the app2 backend version 3, we need this. So I'll be pushing this push to hub. So you can also use the command line version to push it to up. So I'll be doing that. So while this is working, let me also use command line to push the front end to up. So I'll come here now and do Docker. I'll do Docker push OADNIO, okay, slash app1 front end version 4. Okay, so you can see that this is pushing, it's preparing to push. So this one has been pushed successfully, I believe, and then mounted, blah blah blah, mounted, and then this has been pushed. So if I now go back to my Docker Hub now, you can see that let me go back to my Docker Hub here. You can see that the last thing I have here is like fast API backend. But if I refresh this now, you should start seeing the apps that we created. So you can see app1 front end, app2 backend are also there now, both of them. So to get this now, so let me do this and now check our pods. So image pull back off. So what will happen is I will delete this pod. Let me even see if I can get deployment. So this is the deployment. So you can see that it's up to date, but it's not ready. So what will happen is let me delete this deployment. Kubectl delete backend deployment. Okay, delete deployment, backend deployment. So you can see that this backend deployment has been deleted. So if I do kubectl get pods now, no resources found. So kubectl gets deployment, so no resources found. Thank you. So now let me try and apply this backend deployment again. So this deployment has been created. Now let us get our pods. So you can see that now our pods is not having error. our pod is creating this container already. So that's the difference. If you are working, when you want to start working with Kubernetes, you take away your mind that you have a local system that you're working with already. You have to start thinking about everything connecting themselves in the cloud, because if you assume that you're on the cloud, for example, you will know that there's no way whatever you're trying to deploy on the cloud can access an image that is just existing in a local system. So for private organizations, they don't use Docker Hub, or you can have private repositories. You can have private repositories where your repository will be private and not be publicly accessible. So most times for private repositories, you can get like a Docker a image repository. So you can have a private image repository. GitHub itself also has an image repository, both free and paid, and even most of these cloud providers also. So Azure, AWS, and the likes, they also all have their own container repository service that people can use as long as they have enough money to pay for them. So and you can see I have to keep getting my pod. So you can see that this pod is running already. So can you see that this pod is running already? So if before our container was not starting because we were having issues of images, but now our backend, our deployment in the backend is running already. So now let us apply the service YAML. So since we know that our backend is running, now I need to create the service for the backend. Okay, so I'll apply the backend service. I can see that this service has been created. So if I do the kubectl get service this time around, so you can see that the backend service has been created. So this is the cluster IP, and it is connected to the 5000 TCP, blah blah blah. It was created 8 seconds ago. So this is Kubernetes. It does not have an external IP. So all of these IPs are just internal to it, blah blah blah. So this is pod 1 HTTP. I think I need to delete this service. That has been a while. So Control C. Delete service. Okay, so now if I get our services, and you can see we have this. So our services, our backend service is running, and our backend pod is running. So the last thing we have to apply now is to get our front end service. So our front end deployment script. Sorry. So our front end deployment script was created, was named front end deployment. There's no script there. So let me come back here and front end deployment. So now this is on. Oh, sorry, forgot to change this to front end. Okay, so the front end deployment has been created also. Okay, so after running the apply now, so this is what we have done to get all of this. So what we now have to do now is, the question we now ask ourselves is now is how to access these apps after running the apply. Okay, so can you guys hear me now? Sorry, can you guys hear me now?
Yes, I can hear you.
Yeah, we
Yeah.
can hear you.
Okay. Yeah. So as I was saying, so now we have deployed this in Kubernetes. So if we do like, if we check, okay, kubectl get service, you can see that our backend service is created. And if we do get deployment, you can see that we have the backend deployment, which is ready 1/1, up to date. There's no changes. We also have our front end deployment up to date. There are no changes. And then if we also do the get pods. So for each deployment you create, a pod get created for those deployment that is going to hold the container, that is going to hold the container of these deployments. So everything is running smoothly and it is fine. So the question what we're not going to be using now is to access our applications. So they are like there are different ways that we can access the applications, and one of them is to use the load balancer aspect. Okay, is to use the load balancer aspect, and how we can do that is just like, because with Kubernetes deploying is a bit harder, because just as you can see, your local system and your Kubernetes system, um they don't have any application together, like they don't have any connection. So to it is a bit harder to um talk to each other. Sorry, it's a bit harder to connect your local system to your Kubernetes system, because unlike Docker, just as I mentioned, there's no direct access. So you have to like create all of these accesses, and there are three major ways. The first one is to use node ports. So if you use a node port, with a node port, you can effectively create different node ports. So like what happens is that if we come back here now and we check this service, you can see that for this service there is no external IP. So what needs to happen is that there needs to be an external IP that can be accessed before you can start accessing your Kubernetes cluster from outside um, your Kubernetes environment. Exactly. Let me put it that way. So what will happen is I'll use the load balancer option, and then the load balancer option is that for each of the service, okay, for each of the deployments we are having, we are going to need to create is for each of the deployments we are going to need to have a service for both of them. Basically, let us put it that way, because for the backend now we have a service already for the backend, and what is happening is that the service is available for the front end to connect to the back end. That's what is happening. But now what will happen is that for us to access, because the way it is, generally you don't want people to access your back end. What you want is that you want only your back end and front end to be in communication, and the only thing you want to expose to users is the front end. So to do that now, what we'll have to do is I'll have to create a new service, and that one will be called the front end service. Okay, front end service dot yaml, front end service dot yaml. Okay, and then this front end service is going to be the one that is in charge of making your front end service alone that you want to make publicly available. It's possible you can make your backend publicly available and the likes, but then because our time is almost gone, so we'll just create a front end service, and then we'll try and access our front end service. So let me just go to the backend service and then lift all of the things that we need, and then just make the additions. Okay, so this is just like uh sorry, so this is like just like the backend service. So the major thing that is going to change now is that this is a service, okay, but now this is going to change from backend to front end as expected. But instead of having a cluster IP, what we'll be having is a load balancer. Load balancer. Okay, so the load balancer, what the load balancer does is it allows us to be able to connect this service that is running inside the Kubernetes. We're able to connect it. It has an external IP, and then the external IP is accessible. The external IP that is created is what you can then use to access your Kubernetes cluster, basically. So for the load balancer service, we are now going to specify the ports, and then these ports, we say that okay, the ports we are targeting this time around is port 5000 as expected. Okay, let me check the backend service. Okay, no, let me make this one 3000, and the target port. Okay, so the target port is what is port for the front end. Our front end is on port 9000. Okay, so let's place this on port 9000. Let me confirm that the front end deployment. Okay, the back end is on 9000. We will have a bit of an issue. Let me confirm this using the Docker Compose. So the backend is on 9000. So let me go to the backend deployment. Okay, 9000 makes sense. The front end is on 7000, makes sense. But then the backend service, yeah, this is where the issue is. The backend service should also be on 9000, because we are trying to connect our backend service to the ports in the backend app. So previously this would have, okay, let me just leave this. Hopefully we have enough time to come and change this. Let me leave it so that we'll just see the error. So let me finish with the front end service. So we know that the front end is on port 7000. Okay, exactly. So the front end is on 7000. So let me save this. And then now I will now run the kubectl apply for the front end service. So kubectl apply, and then this is going to be front end service the YAML. So you can see that the front end service has been created. So now that the front end service has been created, so if I do kubectl get service, you can see that this is saying pending. So the reason why this is pending is because it's the process of, that's one of the issues that we have with Kubernetes and stuff. I think I mentioned this one time. So you have to keep running like the get service or something to see the status. There's no way you can automatically get updated. The only way you can do this is if you can use a wait option to say that, okay, when you are creating this, wait before you show me another terminal where I can input, wait until the process has been created successfully. So let me keep getting service. So this will keep it will be pending. Okay. So what happened now is that we need to wait for an external IP. So this external IP is going to get created, and if we have the external IP, we can then use that to access our Kubernetes service. So with this now, we are going to like effectively get this, but then we'll have an error when when we eventually access our app, because previously this was on 7000, but what we should have tried to target for the backend is 9000. So let me just save this so that by the time we see the error, I can then just come and do the apply. Can just come and do the apply. Okay, yeah, sorry, I just had to like attend to something. So we are still waiting for this external IP to get assigned. So I just hope in the next 2 minutes before this live coding session gets over, the external IP get assigned. But that's basically everything that you will need to access it. So once this IP gets assigned, all you just have to do is you are going to lift this IP from this particular aspect, and then with that you can access your app. So the reason why we're using load balancer is because load balancer has a lot of, it has a lot of advantages, because with a load balancer you can also start including things like automatically creating multiple ports. So it's inside a load balancer kind of access that you can say that, okay, if a new replica gets created, I want you to assign it to this particular port. If a new replica gets created, assign it to this particular port. The other method you can use is the node group. And if you want to get the node group, you are going to have to create it in the YAML file. Basically, you are going to have to create a node, and then when you create the node port, so it's just like that kind of method is not really advised, because it gives access to the node itself. And because it gives access to the node itself, and we are trying to ensure that our Kubernetes clusters is isolated. Exactly. So the preferred methods are you using the load balancer type of access, or using the ingress type of access. And if you want to use the ingress, what you can just do is you also create an ingress, and then you need to configure a DNS, but that one is more advanced, and that's the standard. So if I come here, for example, and say and do something like creating an ingress service, you can say Kubernetes. So they will have a lot of example, because creating an ingress is it was exposes your HTTP. So what is ingress? It exposes the HTTP blah 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 from outside the cluster to services within the cluster. So that's what this does. So you can see that there's even something about ingress managed load balancer. So you can have an ingress inside, then your ingress is what accesses your service, and your service access your pods. So just like you can see that we have two pods, but we not directly create those pods. We created the service, that's the deployment and the service, and it was that service and deployment that was in charge of creating these pods. And now what we now did is we were connecting a load balancer directly to our service, but in a more granular aspect. What you do is you first create an ingress, and then you create a load balancer to your ingress. So you must have an ingress controller and all of the like. So this is how you create an ingress basically. So you the spark the you create the class name, then you first that okay, this is under the backend service, these are the ports. So this is how you create an ingress, this is how you create it basically. But then the metadata blah 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 was a valid subdomain name. So this is like a little bit into more of networking, and you can read more on it when you have time and as you study further. But the load balancer is also a very very easy way, and our IP has still not gotten assigned. So it's taking quite some time. But then, because this is not going to be running on your local host, the reason why it takes some time to assign your IP is because this IP that will be given to you is accessible anywhere as long as you have internet. So it's not as if it's on your local host. The IP that gets created, if it gets created and I share it to anyone, anyone can use that IP to access this minikube cluster, even though it is running locally on my PC. Because minikube is as though it's just as if you had hosted your minikube on another platform, maybe AKS or whatever Kubernetes. As long as it's Kubernetes, the external IP that gets created um, will be usable by anybody to access it over the internet. But I don't know, unfortunately, this has not gotten created. So get service. Let me try to get the front end service. Okay. So the port is still pending. So because it's 4:58 already, so I think that's we'll come to a close of our live coding session. So we have gone through all of this process. It's basically almost the same thing as what we did for our it's basically almost the same thing as what we did for the Docker Compose and the Docker connection in the last live coding session. The major difference here is that in this aspect, we have used Kubernetes rather than Docker Compose, and then what we are using to deploy. So everything I've used for deployment, this backend deployment scripts, and also the backend service is in the zip file that I shared. So you can use that to go through it. The only issue is that in the backend service, the target port in that file will be 7,000. You have to change it to 9,000, and then you can basically use the same deployment script for the backend to deploy the front end. The only difference is that you have to specify the image name. So if you guys also use this image name, it will work because my image is publicly accessible. But if you try to use an image that you created yourself, you have to ensure that you push that image to your own Docker hub before you can access the app in your Kubernetes cluster. So that will be the end of this live coding session. In the next live coding session, what we are going to try, what the course is going to be about, is a continuation of Kubeflow. But this time we'll be introducing Kubeflow, how to use Jupyter notebooks on Kubeflow. And hopefully by the next live coding session, we are still trying to work on ensuring that we also have a Kubeflow running on a Kubernetes cluster that we can showcase. Well, with that, we have come to the end of this live coding session. Any questions, as usual, you can direct them to Slack and we'll be on hand to answer them. But then, as I always say, this concept might seem a little bit complex at first, but all it takes is just enough practice, and as long as you try and practice and keep on learning, it's over time it becomes a part and parcel of you, and you can also begin to teach this concept to other people. So thank you for attending today's live coding session. See you guys in the next one. Bye.